Hello, Algebra 2 folks. We're describing key features of graphs today, so what we're going to need are our notes, pencil, foldable, and hopefully some other colors, whether they're markers or colored pencils. With that, let's get started. Our learning targets for today are threefold. I can determine where local maximums and minimums are on a graph. I can determine where a graph is increasing or decreasing and state the intervals at which they're increasing or decreasing. And I can find the x-intercepts and y-intercepts of the graph. So this is what your foldable should look like. It has four little flaps. If you're confused on how to construct it or build it, this would be the back side on the green lines. What yours are all black, but if you imagine those lines to be green, we fold there, and if you imagine those two little red lines to be red, that's where you would cut, and then on the blank side of the paper, right in here, that's where you would glue it into your notes, okay? Okay, now we're on the inside of the foldable. We're going to start in the top left-hand corner of the inside of this foldable, or on the flap that reads X and Y intercepts on the outside. So as we go along, notice the colors of what I'm writing in words and how that matches the graph or the parts of the graph and the colors on that picture. So the first fill in the blank that we want to fill in is the x-intercept is the point or points where the graph crosses the x-axis. So in this particular example, I have three x-intercepts, and they are the points -3, 0, 1, 0, and 5, 0. So notice how I'm keeping my vocabulary all the same color. So for x-intercepts, we're going to keep that color-coded purple, or if you're picking a different color, maybe keep it all the same, okay? So next we're going to talk about the y-intercept. The y-intercept is the point where the graph crosses the y-axis. And in this example, it's the point 0, 2. Intercepts are something that we should be familiar with, but if we're not, that's a quick recap. So if we keep moving on down the left side of the foldable, now we're going to be talking about intervals where our graph is increasing and decreasing. So a function is increasing on an interval if the y value increases as the x value increases. So we're looking at the graph where both of our values are increasing. In this example, we're increasing on that first bit. So when we read from left to right, we're starting on the y value at -infinity all the way going up to the value of the y value of 4. And then we are also having another increasing interval, and that starts at the y value of -4 and goes on for forever in the positive y direction and x direction, okay? A function is decreasing on an interval if the y value decreases as the x value decreases. So in this particular example, it's that in-between space of our increasing intervals. So increasing and decreasing are easy to notice by our eye because we read from left to right, but sometimes writing them down as a notation can be difficult, but we'll practice that in the next two examples. Okay, next flap. The maximum is the y value of the highest point in a particular region of the graph. So in this example, my maximum is -1, 4. So it's that green point, that high point, that's my maximum. The minimum is the y value of the lowest point in a particular region of the graph. And in this particular example, it's the point 3, -4. So that's my minimum, or where the graph is dipping. The maximum is where the graph is peaking, and the minimum is where the graph is dipping. Okay, the last little flap is talking about zeros, roots, solutions, and x-intercepts. Those words are all interchangeable, you guys. Zeros, roots, solutions, and x-intercepts are all the names that describe the x value of a graph whose corresponding y value is 0. So whenever I use the word zero, root, or solution, this is the same definition for all of them. They all go back to x-intercepts, so the x value when the corresponding y value is 0. So make sure we get all of those words inside of our foldable and that we've highlighted or color-coded our key features on our picture graph. We have two examples that we're going to do inside of our notes. On both of them, we're going to find all of those key features that we talked about in our foldable. So the first thing we're going to find from this graph is the x-intercepts, or the points where the graph is crossing the x-axis. So that's this point right here, this point, and that point. And those ordered pairs are -4, 0, -3, 0, 1/2, 0, and 3, 0. Now we want to find the y-intercept, or where it crosses the y-axis, and that's at this point or ordered pair right here, and that ordered pair is 0, -2. Now we want to find where the graph is increasing and where it's decreasing. When we say that we want to find that interval, we're going to use our x values, or our x-axis, and those numbers on that number line to describe where it's increasing and decreasing. So on our graph, here I'll use a different color, I'll do green. Our graph, if we read it from left to right, we're going up, 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 up until this point right here. So that increasing interval is x is less than or equal to -3.5. So we're writing this like we would domain, but we're just recognizing it as an interval on our graph when we're watching. So from that point, then we go down all the way to here, and then my graph is going up again, or increasing all the way to this point. And that interval is the x values of -1.5 to 2, where x is in between those two values. So then from this point on, my graph is going to decrease. So those two intervals, when our graph is decreasing from this point to that point and this point to that point, are these two intervals, -3.5 less than or equal to x less than or equal to -1.5, and x is greater than or equal to 2. So we're writing those inequalities, or in inequality notation, but we're recognizing where our graph is increasing and decreasing according to the x values on our graph. We're referencing the x-axis in order to come up with those numbers. Okay, now when we talk about maximum and minimums, remember though, we're using y. We're using the y value of our max and min. So we have two maximums and one minimum. Our first maximum is here, and our second maximum is here. Those y values are y is equal to +1, and y is equal to 5. And then our minimum is down here. And that y value is y is equal to -5.5. It's between the y value of -5 and -6. Okay, now let's talk about the whole graph's domain and the whole graph's range. So the domain of this graph is my x values, so we're going from -infinity all the way to +infinity. So what that's going to look like as an inequality is x is between -infinity and +infinity, or we write it as -infinity less than x less than +infinity. If there's no sign in front of the infinity, it's assumed to be positive, okay? And then our range is all the y values, right? So all of the y values on our graph. So my graph is not crossing this y value, which is the line y is equal to 5. So it's not crossing that, it's below that. So my range is going to be y is less than or equal to -5. Okay, and that's our first example, and we have one more example for our notes. Okay, so our last example, my x-intercepts are -1, 0, and 3, 0. My y-intercept is 0, -3. Increasing and decreasing intervals. Remember that we're going to be using our x values on our x-axis to figure out where it's increasing and decreasing. So if I read this graph from left to right, I'm going down all the way to the point 1, -4 right here, and then from there I'm going up. So my increasing interval would be x is greater than or equal to 1, and my decreasing interval is when x is less than or equal to 1. There are no maximums on this graph, so on this one you can say none, because the top of my graph is going on forever and ever and ever and ever, so it's never going to stop. So we technically don't have any maxes. And then my minimum is at the y value, y is equal to -4. Remember, for maxes and mins, we talk about y values, and increasing and decreasing, we talk about x values. Okay, domain and range. So on the whole graph, my x values are from -infinity to +infinity. It's covering all the numbers. So we write that as -infinity less than x less than infinity. And then my range is everywhere above that line at y is equal to -4. So my range is just going to be y is greater than or equal to, oops, sorry, -4. It should say -4. Okay, I want to thank you all for taking good notes, and I shall see you soon.